we need to maybe change our mindsets to say, does this data need to be for my company only? And if yes, fine, but there will be other pieces of information that could be of use to others.
Welcome to FNet Silica's We Talk IoT. We'll chat with innovators, experts and business owners to learn how they are implementing IoT and using data to create new business opportunities. I am your host, Stephanie Ruth Haydock. By 2050, over 2.5 billion people are predicted to live in cities. How can our roads, public transport systems, and our nerves sustain this? As cities keep growing and infrastructure suffers, can IoT and data help? A smart city can leverage data sources, from vehicle movements to energy use and water distribution. If you put all this information into context, city planners and citizens alike can make better decisions. But what does it take to make a city smart? And what are the essential resources? To answer these questions, we have invited Marek Suchocki, Senior Global Business Development Executive at Autodesk, to the show. Spoiler alert, the building block for our future is data. So, Marek, thank you so much for taking the time just to get us warmed up. Would you like to introduce yourself?
Yes, hello everybody. My name is Marek Suchocki. I work for Autodesk and I'm based in the United Kingdom, just southwest of London. My role is a Senior Global Business Development Executive. And whilst that is a long title, my role is about engaging with industry and being a spokesperson on a number of subjects, mostly related to engineering and construction. I am a chartered civil engineer and fellow of the Institution of Civil Engineers, as well as a fellow of the Chartered Institution of Civil Engineering Surveyors, and also a fellow of the British Computer Society and a chartered IT professional. So hopefully those titles give you a flavour of my track record and history. I've been in industry for over 30 years, working as an engineer initially, but then quickly moved into the area of what we now call digital construction and also the transformation of the sector. I have been a representative of the British Standards Committee that has written guidance around information management for construction that has become also the ISO 19650 series of international standards. I also get involved in open standards communities for construction data, such as Building Smart, where I sit on their steering committee for infrastructure. And again, I hope this kind of gives you an indication that I'm not just about talking about my own current employer, Autodesk, but also from the industry where I did spend 20 years as a practitioner.
Yeah, I'm really excited to ask you the many questions I have about smart cities. Before I fire at you, what is you work for Autodesk, and for our listeners who might not know this company, what does Autodesk do?
So Autodesk is one of the world's largest providers of software for engineering and construction, architecture, the manufacturing industry, and also media and entertainment. So if you've driven a high-performance vehicle or even a family vehicle, if you've stayed in a luxury hotel, if you've used a train, driven down a highway, it's highly likely that those vehicles, those buildings, that road infrastructure had been designed using some of Autodesk software. For over 20 of the winners of the Best Visual Effects Oscars used our software in a kind of one after another. So some of the greatest films you've watched and some of the games that you've played, they've all had some use of Autodesk technology. So we're kind of everywhere. And yet, I think, Ruth, to answer the point you're making, actually, a lot of people haven't heard of Autodesk.
Yeah, it's really interesting because when you think of smart cities, I think the last thing you would think about is software. It's actually you guys who build the smart cities, isn't it?
The interesting question or point, I think the aspiration of a smart city is that information is integrated, that whether you're a citizen or a manager of a facility like a building such as a hospital, a hotel, a school, that that data has to come from somewhere. We also have to have spatial context. We need to know where we are. And quite often we get devolved down to a more geospatial layer. So we're looking at it maybe like at a map level, and yet that's not got the detail that we might want. So Autodesk plays a very critical role in giving that more local context, because our users design buildings, as I said, design highways, design rail infrastructure, design water infrastructure, and they can actually give you the accurate representation of the thing, the asset. So, yeah, our software really is quite intrinsic to enable smart cities to be a real kind of thing, because without knowing perhaps what floor of the building you're on, what thing you're looking at, if I'm a maintenance operative, which light bulb do I need to replace? And that kind of comes down to a very more accurate representation that could well come from the use of our software. So, yeah, we're certainly part of the smart city enablement. And I'm sure during the rest of this discussion, we can go on to look at some of the ways that we can help bring data together, so that it's clearly not all about us, but we are almost a critical factor.
And from your perspective, what does make a city smart?
That's a very interesting question, because a smart city, I think that the kind of the terminology has been around for over a decade, and for some time it was talking about the context of where someone might be, what information is there around them, how does my vehicle get charged, and it was a provisioning of information to a user or a piece of automated machinery, and I think that still remains, but we're getting more and more into the area where we can predict how things might behave, that we can adjust automatically. So a smart city would hopefully avoid traffic jams, because it would route people, our satellite navigation would be linked up such that our vehicles would know that they need to go a different route because there might be a blockage in a typical main thoroughfare. But actually, because there's been an accident or some other reason for the blockage, we can actually navigate around it. And that relies on multiple data sets being integrated. We are certainly seeing that in a number of let's say, advanced areas. Interestingly, London, for example, Transport for London published a lot of their data as open data many years ago, so that other providers, such as people who prepare apps for you to do route finding, can consume that data and, again, allow them to adjust on the fly as to what's the best way to get from, the Houses of Parliament to Oxford Street, whether it's walking, using the tube, taking a taxi, and it will give you all the options because it's giving dynamic, up-to-date information. So what makes the city smart? I think it's having the data first and foremost available in a structured form, having integrations between other data sets, so people talk about mashups, and having access to that data to the right people. So I think as we build more and more useful information sets, then we can start creating smarter and smarter cities and services to people and assets alike.
That's an interesting aspect you just mentioned, the open data. Is that something that many companies or governments are already living, or is that still? I could imagine that many people are still holding on to their data and not sharing it willingly. Be interesting.
Yes, I think you've hit on perhaps the great challenge we face in enabling smart cities, and I think people I'm sure have raised the topic of digital twins on your podcasts in the past. All of these things rely on having usable, valuable data to make decisions or simulations, and the security of that data is, of course, paramount. And I think that this is an area that has actually been explored at length. I mentioned that I'm part of the British Standards Committee that's written the UK government guidance around building information modelling. but also that's become the ISO 19650 series of standards. One of the core components of that is Part 5, and 19650 Part 5 talks about security-minded information management. What this means, it's not a approach to say, I'm not going to publish or release anything, everybody has to be highly secure. It's actually to say, when we create information, do we consider its security? So we talk about things like national critical infrastructure in the UK, and I'm sure other countries use similar language, which says, this piece of infrastructure, maybe a highway, piece of rail, a bridge, a building, is absolutely vital to our national security. It's it may be a government building. It may just be something that, if that road gets closed, then we have some major challenges ahead of us. And so those assets should have a higher level of security imposed on them. And that's the decision as to what level of security we apply to data should come from the asset owner and potentially from the future asset user. And then that is then passed down to other people in a supply chain to ensure that they introduce the right rigor and rules. So make sure that data is secured to only certain permitted individuals. Make sure we use, access rights and passwords to gain access. Make sure we control the description of things, mainly to avoid having people with nefarious and poor intentions to not gain access to that data. But then that's the stuff that needs to be secure. There'll be some information that needs partial security, so it should be kind of controlled by username and password only. But there's an awful lot of stuff that, frankly, doesn't need to be highly secured. It's just valuable information for anyone. And when you consider a game of poker, everybody holds their cards close to their chest, and it's a very difficult game to play. I think smart cities are actually about playing a really bad game of poker where everybody looks at everybody's cards.
Cards on the table.
Yeah, cards are on the table because we end up with a kind of a collective benefit. So, of course, security is paramount and important, but only for the appropriate cases. So we need to maybe change our mindsets to say, does this data need to be for my company only? And if yes, fine, but there will be other pieces of information that could be of use to others. I'll give you one simple example that I think every person gets really angry with, whatever country you live in, which is you'll drive down the road or you're walking your own road and somebody will be digging a hole. They'll be, repairing the telephone lines or installing your fiber optic cables. 2 months later, in exactly the same location, somebody comes along and digs that same patch up because they're changing the water pipes or the gas pipes. And this kind of services challenge has existed because those different utility providers have not shared their data in the past. I'm pleased to say in the UK, about 10 years ago, this was recognised and efforts were made to get some coordination around that work. But it doesn't mean that they're necessarily sharing their data as well as they could. And so what we need to ensure is that everybody is aware of other people's location information, but also, in this case, plan of work. Let's program things together so we dig the hole once and we do 3 jobs there and cause the minimum disruption. Obviously, it has a positive impact on the condition of the road surface when it's reinstated. So I think that's a very simple example of where sharing information at the appropriate level can avoid disruption and frustration for citizens as well as the actual providers.
And in the end, it would probably also, everybody would benefit from it because you would only have to pay the guys who rip up the street once.
No, exactly. Absolutely. And whilst that's a kind of not necessarily a smart city example, it is talking about the openness of data, making the data available. And actually, in that case, what we're not saying is that data needs to go to the public. It's data that's provided between public service providers so that they share that information freely and they can actually coordinate more appropriately. So, it's a kind of that middle layer of security where it's a controlled data set, and it requires it kind of a change of thinking because it starts to say, when we plan our work, we need to plan in coordination with others who are adjacent to us. There is a final benefit, actually, of course, is the avoidance of strikes. By that, I don't mean industrial strikes. I mean about striking a service. So, if you're digging a hole and suddenly you cut through a fiber optic cable, that's going to cost a lot of money to fix. But if you know there's a fiber optic cable there because the data's available to you, then the gas provider or the water provider who's digging that hole is at least going to take additional precautions to avoid those kind of incidents. So there's a lot of benefits about being able to share this data more freely. And I think that's a kind of use case that is applicable wherever you are in the world.
Wow. And it seems to me that this mindset is something that you are living with the building information modeling already, right? That you, as an architecture in the architectural engineering and construction industry, there used to be lots of paper plans and lots of different companies involved in a building project, and everybody would carry their plans from here to there and back again. And but with this BIM approach, as you've mentioned, the data is available to everybody, and yet then you can see all the layers that before you might not have even known that this is a valuable information for you. But now that you can have a holistic approach on a project, I guess it comes all together, and this is a mindset that is very valuable for this industry, I guess.
Yeah, I've kind of lived through the transition from what we saw CAD, so computer-aided design or drafting, to now BIM, building information modeling, and a kind of a middle way between that was 3D, where we started to look at things not just in a two-dimensional representation, but in 3 dimensions. And what we started to do is actually first have a better appreciation for what the physical asset might look like. So, once we go from 2D plans to 3-dimensional representations, we can start avoiding clashes more easily, because things that were maybe building services would hit structural framing, that can be avoided in the 3-dimensional representation. But as soon as we start getting additional valuable information about the thing, the asset, then we can make different types of decisions. So what the I in the BIM is information. So when we talk, I mentioned some building services. So there could be, electrical cabling, it could be plumbing going for a building. If we know exactly the voltage of the cables, what they're carrying, what kind of pressure is the water at, then that helps the person who's designing the next associated asset, maybe a pump or some sort of transformer, because they're immediately grabbing the information from the interaction of different assets. Similarly, the steel frame knows exactly what what kind of grade of steel it is, what depth and width the actual member is, and all of this information helps us calculate quantities. We can do costing straight off of it. We can start sequencing work more easily, and it's a step-by-step transition, but actually it's quite a substantial one, where the ability to leverage that information and the data behind it to make better decisions is really changing our approach to designing the physical assets that we live and work and play in. I think it's always been an opportunity that maybe the manufacturing sector has had a easier chance to get hold of. When you think about a car, that car will be built hopefully hundreds of thousands of times to give money back to the manufacturer. How many houses do you see built the same? Quite often they're all individual and they're unique, but that doesn't mean we shouldn't try to approach it by going to that more granular level of design, so we have better understanding of the physical asset that is being created.
This podcast is brought to you by FNet Silica, the engineers of evolution. If you want to learn more about us, we have put information and links in this episode's show notes, and you can also connect with us on LinkedIn or avnet-silica.com. That's avnet-silica.com.
I know these podcasts are around IoT as a kind of central theme. So why don't we also start inserting sensors into those physical assets that we construct and live and work and play in? Because then we can start monitoring their performance in use. We might get early awareness of them if they have to have some maintenance done on them. But we also will have just some better knowledge for our asset management and facilities management system. So if you have a door with some sort of IoT sensor device in it, the maintenance worker can go up to it, scan the device and say, I know which lock to insert, I know the key to pick. So there's a lot of very simple benefits that can be achieved by sensoring up those assets. And all of that data goes back to the model. The building information model can tell us those unique IDs and information about the things that have been designed and constructed and operated.
What do you think are the biggest challenges for the architectural engineering and construction industry at the moment?
I think resource is possibly the one that's most challenging. I regret that the construction sector has typically been quite unattractive to young people. It has a perception of being very male-dominated, quite, I'll say, adversarial, aggressive, masculine, often in poor weather conditions, which can be true. And actually, to some extent, this remains true. But actually, it's such a fantastic industry to be in because it is the greatest provider of global GDP. The employment of the construction sector at large is bigger than any other industry because, every country builds roads, every country has houses, every country has schools, prisons, offices, hotels, I could go on. And the opportunity to do that better is one that BIM has really triggered a change in. But do we have the right people in the industry today to follow through on that opportunity? Are we bringing in new people to exploit that potential opportunity? I'd have to say no, because there is still a perception that the industry is for, I've got to pick my words carefully, but, for people who maybe have lower achievement at school, who are more physically minded as opposed to mentally minded. And the truth is it can be for everybody. So, I mean, it's a shame that the perception doesn't meet the actual reality. But in order to get that additional resource, we do need to portray ourselves a bit more differently, make ourselves more attractive to new entrants. And one final point on this is that I think we have a huge focus globally around environmental sustainability. We've had all the COP summits. What is going to be the best way to achieve carbon reduction? What's going to be the best way to improve our use of energy? It's going to be designing better buildings, designing better infrastructure, using different power generation.
Isn't it that old buildings cause 30% of carbon emissions in some countries? It's a very high number. I don't quite remember exactly, but like old buildings that are not
renovated.
Yes, thank you. Yeah.
I mean, look, that's a very critical problem we face. That, I think we talk about every year we only build 2% of new assets, whether that is roads or buildings. So really, we're living with 98% old stuff always. And, of the buildings that will exist in 2050, 85 to 90% of them exist today. So when we look at, doing things better from new, yes, of course, we can do new stuff better. But you're right, we do need to renovate and improve our existing assets to target those quite damning figures. Like, if you say it's 30%, then that's quite a concern. However, renovation, retrofit, all of this is possible. And actually coming again back to BIM, some of the work that we've done in Autodesk with research partners is around concepts such as rapid energy modeling, where we would use new technologies like laser scanning or drone surveys to capture the physical representation of an existing old asset where we don't have models. We may not even have the drawings because it's so old, or the information management regime is so poor that the record keeping was lost, or it was in a basement and, for whatever reason, it's no longer available. But we can actually get a good understanding of building three-dimensional new models. And then on that, we can start simulating and forecasting what a change might be, changing the cladding, improving the insulation, changing the boilers and the heating systems to a new model, improving the roofing, whatever the kind of decisions are. We can run different scenarios and say, well, actually, this old building that we definitely want to retain because it's got architectural value, but we can actually improve its energy performance because we can actually model it from these new kind of surveys that we can create from, as I said, laser scanning or drones or photogrammetry of another sort, and then start saying, well, if we make these changes, we'll actually, even if it's a small 5% improvement, that's still going to have a huge impact if we do this across the large number of buildings that exist. So the opportunity is high to change what we already have by applying new ways of thinking. And that all comes back to having the right people with the right mindset, able to understand that this is a possible approach.
Is there a smart city project that inspires you at the moment? Something that is where you think this is where everything came together perfectly. This is really state of the art. I would like to see more than that.
Oh, that's a tough question to answer.
Sorry, yeah.
Yeah, I've seen.
What's your favorite book?
Yeah. Now I've seen a number of examples of things that have improved my own experience. I think smart cities are still a aspirational state. What we are probably seeing more are more local examples, and this might come back to the idea of a digital twin, where maybe airport operators have improved their management of data because it helps them manage and operate what is a city in a more small context rather. I've done work with Heathrow Airport over nearly 20 years in both of my time at Autodesk and previously when I worked at Atkins, and they've been an exemplar in understanding the value of good information management and data management. They've got somewhere in the order of 80,000, I think, kilometers of utilities running underneath the airport, most of which they don't own because it's from other service providers. They are one of the biggest shopping centres in London because, we all go to airports and we all like to do some retail therapy. And they need to be able to manage the concessions for those retail areas. They need to make sure that the ones on the land side and the air side are managed differently. So, before and after security is different. They've obviously got security operatives, got all these airline operators there. They have plane movements, they have people movements, and that all relies on really good data management and information management. And maybe that to me is where, if other asset owners headed in a similar direction to airports, then I think we'd start seeing the reality of smart cities come to fruition. And actually, local digital twins are a starting point for that as well. If I get good at managing my own stuff and I'm open with the data I can release, then I think we now are going to get closer and closer to creating that smart environment that we can live and work and play in.
Well, that's really interesting. I think many people always think global first and then local last, but I think that mindset is also a little bit changing. So you can benefit on a small level from big technology as well, and then scale it to a city, right?
Yeah, and you also create that jealousy, perhaps, or that desire. If you see it, you want it. And I think many of the customers that we speak to say, "Well, I want Matt. I want BIM," was like an old question, and I want Matt Digital Twin. You've provided, also a technology called Tandem that we've been piloting for the last couple of years as a digital twin solution, and we're seeing a lot of appetite saying, well, why is that customer got it? I'd like some of that. And so if you can start creating that desire to have what others have got, because it helps them improve the way they perform, productivity, then that's great. And actually, funny enough, my point about resource shortage, who would you rather work for? Would you like to work for a company that is using advanced technologies, virtual reality headsets, laser scanning, or someone who's still working with a pen and ink in an old kind of world? Of course, young people want to go for the technology-enabled businesses because it's going to give them a more enjoyable work environment and hopefully better career development.
Yeah, to be honest, the more I learn about BIM and smart cities, if I would be able to do it now, for me, I think it's a little bit too late now. But if I had known how information driven, how IT driven, and futuristic construction could be, I would have been interested in doing that, to mix the theoretical and the computer stuff with actually building something and seeing the result of your work at the end of the day or the project time.
Yeah, and I'm delighted that I've kind of lived through that transition and had the chance to be a change agent to some extent in helping the companies I've worked for and other businesses adopt new technologies. It's not easy, but I think it's an inevitable transformation that all industries have to take. We've got to pick up the potential that digital offers to it. And there's a bit of learning by doing. We don't have all the answers in the best way to do it. So your questions around smart cities, I was probably being a little bit unclear in my answers because I'm not seeing the perfect answer. There isn't a perfect solution out there. But those who are doing incremental improvements, they're inspiring others. They're creating that jealousy I talked about. And so if you can be part of that change, that's a great career. And actually, just a final point, and I've said this to many young people that I've spoken to, is don't think that, if you go to university and get a degree in architecture or get a degree in civil engineering, that's the job you're going to do. When you enter the industry, you can take different paths, environmental sustainability we talked about. You could do building services, structural engineering. You can do construction site work. You can do design office work. You can do project management. You can become a government procurement officer. There are just all sorts of roles you can go into because you can pick up the path that suits you best, and you can change. You can become a multi-talented and multi-experienced human being, which I think would, for anyone is a kind of a career to aspire to.
Is there anything else that I have missed? Is there anything you would have wished me to ask you?
I think the only thing we haven't covered is data integration and to some extent standards, but maybe the standards kind of will come anyway. But in order to create digital twins or smart cities, we do need to make sure that data is interoperable. And that relies on having the data being correctly structured. We need to make sure that we call things in a consistent manner, at least one that can be mapped to another. If you imagine any organization that has an asset management system, so SAP, for example, has an asset management module that many companies use, have the users describe the assets in that system in the same way that the designer described the assets. Are we talking about the same staircase? Are we talking about the same door? Are we talking about the same window, the same bathroom? Because if they're described differently, then we cannot associate that information. So there's a fundamental need to codify and classify information consistently and then build the interoperations between the different systems. Because what we don't want to see is saying, oh, well, I've got to buy a brand new smart city or digital twin technology, which is some mega new system that would mean that all the other systems become obsolete. What we need is actually to bring data together and keep it in the original systems managed by the people who are experts at managing it. And that requires interoperability in data formats, in system APIs. So that there is a lot of work needed. And I'm very pleased to say that Autodesk is really driving the change. We have our own technology platforms that provide a set of tools, APIs and applications that people can leverage to build their own integrations and their own solutions. So we're kind of we've got a kit of parts, but we're not giving you all the answers. So I think that's a really critical thing to consider as well, is make sure you can link the right data sets together, make sure you name things correctly. And so there is quite a bit of work, and that's probably where I've spent a lot of my time, is around the information standards and making sure that they're consistent globally. Because again, we don't want the different standards in every country, because then we don't have any standardization. So
Yeah.
The more we can do to have standards around data protocols, APIs, and so forth, the better we'll be about sharing and information.
I'm curious, how does this work? How do you get a global community of engineers agree to a standard?
So I think what we've done, certainly I mentioned the ISO 19650 series, is that there has been involvement, I'm very pleased to say, from national industry standards bodies, so DIN in Germany, for example, British standards, Norwegian standards, Norway, and so forth. So the whole community has come together and they've kind of had a consensus on the standards. They are also subtly non-restrictive in that there's a kind of a high-level recommendation, but when you get down to the detail, you can do that locally. So you can apply local data classification, for example. So you don't have to say, we'll do it all the same way that the British people have done it, because that would not work. So what we say is, follow these protocols, follow this process, but you can also adjust locally. And that means that we don't have to throw away all the work that's been done over hundreds, if not thousands of years of the construction industry existing, and yet still kind of all move in the same direction. So, we use the same methods to assess whether we have security considerations. It's not a different process. This allows competition to exist. So people can actually work in different countries because they're following the same processes, but you just have to understand the local norms. I think that the BIM, which we talked about earlier, is actually maybe a catalyst as well, because without BIM, we were going to do it all the same way we used to. Now we've introduced a new kind of suite of technologies. People are still learning about it. So if you learn and you learn the standards that others are using, then you don't learn a different language. You're learning the same kind of methodologies and languages. So I think there's a positive to be had by introducing a new set of solutions like BIM.
Cool. Thank you so much, Marek. It was great to have you on the show. Thank you so much for a great discussion about smart cities.
Thank you very much, Ruth, and thank you for inviting me to speak to you.
This was Avnet Silica's We Talk IoT. If you enjoyed this episode, please subscribe and leave a rating. Talk to you soon.